rate constant. Let's say we have a equation where N2O5 decompose to give NO2 and O2. When we plot a graph of rate versus concentration of N2O5, we will get a straight line graph. It means that the rate is directly proportional to the concentration of N2O5. Or, if we substitute this symbol with equals to, we have to write a constant. The constant used is K. Then we will get rate is equals to K concentration of N2O5, where K is the rate constant. It tells how the rate of the reaction depends on the concentration of the reactant. Now, let's discuss about rate law. Some chemical reactions occur in zero order, some in first order, second order, half order, 3/2 order, and so on. Let's say we have an equation here. So how to write the rate law? Firstly, we need to write the word rate. Rate is equals to, then we write the rate constant, K. For rate law, it only involves the concentration of the reactant only. Since now we have only one reactant, so we just write concentration of N2O5 to the power of X. So what is X? X is actually the order of the reaction. Okay? And how can we get the value of X? Value of X, we can only get it experimentally. And value of X is not, this value of X is not from the stoichiometric coefficient. For example, the stoichiometric coefficient is 2. Okay, let's say we write rate is equals to K concentration of N2O5 to the power of 2, meaning that it is second order. And we get this value experimentally. This value does not indicate the stoichiometric coefficient. Okay, let's say this equation undergo zero order. Let's say it is zero order. So how can we write the rate law? So we write rate is equals to K concentration of N2O5 to the power of 0. Or usually we will just write rate is equals to K only, because any value if to the power of 0 is just 1. And what if the composition of N2O5 is first order? So if it is first order, to write the rate law, we write rate is equals to K concentration of N2O5 to the power of 1. Or usually, we will just write rate is equals to K concentration of N2O5 without number 1. And what if it is second order? If it is second order, so to write the rate law, we write rate is equals to K concentration of N2O5 to the power of 2. Remember, the order of the reaction, we get it experimentally. Okay, the question is either the question will give the order directly to you in the question, or sometimes the question will give you hint, okay, on what is the order of the reaction.